series and parallel arrangement of resistors. Now, resistors in series, let's start with that one, series arrangement. Now, let's consider this diagram here. Consider this diagram here. Now, note generally, in series connection, that number one, the same current passes through each resistor. So the same current passes through each resistor to R2 to R3. Then note another one that the potential difference across each resistor depends on the value of its resistance. So that means R1 have its own PD, R2 have its own PD, that is V2, then R3 have its own PD, that is V3. Now, note again, the potential difference V across the whole series connection is equal to the sum of the individual potential difference across each. So that is V equals to V1 plus V2 plus V3. So from here, look at it from this diagram here. So let me illustrate it here. So there's the total PD. So here is V. Now, finally, the total resistance R is the sum of the individual resistance. So that is R is equals to first ohm resistor plus second ohms plus third ohms resistor. So that means from this diagram here, everything here, so there is R, say the total resistor in this circuit. Now let's look at the parallel resistors. So let's consider this diagram. First ohms, second ohms, third ohms. Note the combined total equivalent or effective resistance for resistor connected in parallel is 1 over R equals to 1 over R1 plus 1 over R2 plus 1 over R3. Now, if there are two resistors, that is R1 and R2, the combined resistance will be 1 over R equals to 1 over R1 plus 1 over R2. So the LCM, which is R1, R2, so 1 over R is equals to, and the LCM, R1, R2, so R1, R2 divided by R1 times 1 is R2. Now, R1, R2 divided by R2 times 1 is plus R1. So cross multiply to get R into R2 plus R1 equals to R1, R2. Now let's divide both sides by R1, R2. That's R1 plus R2. So that is divided by R2 plus R1, divided by R2 plus R1. So this will cancel this. So R is equals to R1, R2 over R2 plus R1. Now note, in parallel connection of resistors, the potential difference, that's the PD across each resistor, is the same and is equal to the potential difference across the whole connection. So that is V equals to V1 equals to V2 equals to V3. So from this diagram here, so let's illustrate it here, look at it here. So V. Then number 2, the total current is equal to the sum of the current flowing through each resistor. So that means different current go through there. So that is the current there will be R1 plus R2 plus R3. So that is this current here. So first current for first ohm resistor, second for second ohm resistor, third for third ohm resistor. Then finally, the combined resistance is always less than the least individual resistance. So look at it here from this diagram here. So this is the resistance, that resistance.